So this is a third order differential equation, and what we're going to do is I'm going to go through and write my characteristic or auxiliary equation. And so this is going to look a little bit different. My characteristic equation this time is going to be r to the third plus 3r squared minus 4 equals 0. So really, like I said, the hardest part of this is going to be figuring out how we have to factor this. How do we factor this? It's a third degree polynomial. Again, I'd probably use your calculator. If you want to find one of your roots using your calculator, using polysimult, you could certainly do that. If you wanted to look at a graph of r cubed plus 3r squared minus 4, just see where it crosses the x-axis, great, do that. How many of you have do you remember how to do this on your calculator? Oh my gosh. Okay. There's several ways we could do this actually, and Symbol Lab would have one too, so some of you like Symbol Lab. What?
What's polysimul?
Polysimul is an app, so if you go into your apps.
Well, where's that?
The button that says apps. APPS. It's next to one of the colored buttons.
I found it. Oh.
Okay. So if you scroll down to polysimul, that allows you to solve your polynomial equation. And it will actually give you all of your answers. If they're all real, if they're imaginary, it depends what mode you have your calculator set up on. It may give you those as well. Now, let's say it doesn't give you as many as you would like. How many solutions, how many roots should we have? 3. That's the fundamental theorem of algebra. This is a third degree polynomial. I have 3 roots. If I know r equals 1 is one of my roots, because that's what you'd get using polysimul. If you graphed r cubed plus 3r squared minus 4, you'd see it cross at r equals 1 or x equals 1. You guys can use synthetic division from here. If this is all you could find, you could use synthetic division. Just make sure you have a placeholder for all of your terms. So I'm going to drop a degree, multiply, do what the signs say, multiply, do what the signs say, multiply, do what the signs say. The whole point is, remember on synthetic division, that last result should be 0. That's your remainder. Which means now my polynomial is r squared plus 4r plus 4. Can we solve that one? Yeah. This is r plus 2 squared, which means I get r equals negative 2 with a multiplicity of 2. Okay, 3 roots. We expected that the characteristic equation was a third degree. 1 is distinct, and 2 are repeated, right? So we're going to treat this as if we have 3 parts to this problem. My solution, if it had been only this one piece right here, we would have c raised to the e, or c1, e raised to the 1t. If that's all I had, that's what I would get for my solution. And if all I had was the multiplicity of 2, r equals negative 2, we would get y equals, I'm going to use a different c, c2 e to the negative 2t plus c3 t e to the negative 2t, because that's what a repeated root does. Right? This is what we'd get for, do we remember this? Is it too early? This was last week. It was just last week.
That was
a whole week ago on Monday.
It's a week and 1 day. Too much.
Yeah, we had like
Yeah.
days off.
Yeah, at the beginning. Is there going to be another day off by chance over the whole firing or no?
No, not that I know of. All right, now, okay, so good news is there are videos in Canvas if you need to go back to that distinct roots or the repeated roots. Remember, we did the distinct and the repeated roots on Monday. So then Tuesday was your work day, right? And then we did complex solutions on Friday. It has been a disjointed, I will admit, a disjointed few weeks. Now what we can do, though, for our final solution for this one is just combine all the parts together. Okay, you can see that we have our real distinct root here, and then we have our repeated root right here. So this is our final solution, is just a combination of all of the parts. See, that's not so bad. The hardest part truly is figuring out your factors.
Is 2 or is -2 a double root?
Yeah, because it was... You don't know how to put what in your calculator?
Yeah,
I didn't either. I
It would
did
be
this
hard.
close. I didn't realize if it closed and I'll be like an hour.
Yeah.
Well, you know what I mean?
Come out.
I had a hard time. I had world lit 6th period. I had 5th off. All right, here we go. Here's another third order. Let's see what happens when we try to solve this one. So try this one. The hardest part again is usually the factoring. And the characteristic equation on this one, we've got the 3r cubed plus 5r squared plus 10r minus 4 equals 0. So I would use your calculator, but you're only going to get one pretty answer.
It's not pretty.
And it's still not pretty. So get your one pretty answer, then we're going to use synthetic division to break this down.
Can you use non-division?
I did a third.
All right. Polysimul, you should get r equals 1/3. Now, let's review some Algebra 2 trig, which has been a while. Jake doesn't like synthetic, so you're welcome to use long division, except I would choose not long division. So synthetic division, we put the r value that we have in that box. Then what we do is we put our leading coefficients. We cannot lose a degree. So this is a 3rd degree, 2nd degree. We have to put a placeholder in case we're missing a term, is really all that means. Then what we do is we drop our first term. Sorry, I didn't realize some of you didn't know synthetic division or remember it. Otherwise, I'd have gone over it on the last one. Drop your first term down. Then we take and multiply these two terms together, the 1/3 and the 3, which is 1. And we put that here. And then we do whatever the signs say. So if one's positive, one's negative, we just treat them like they're signed. So these are both positive, which means I'm going to add them. Then I'm going to take and multiply 1/3 times 6, which is 2. And I'm going to do whatever the signs say, which is 12. And then I'm going to do 1/3 times 12, which is 4. And then I'm going to do whatever the signs tell me, which is 0. If we already know it's a solution, if we already know it's a root, your remainder, that's that last term, has to be 0. If it's not 0, it didn't go in evenly, which probably means you made an addition error is really what it means. We already know this is a solution. Now, why is this helpful? Because now I have a new characteristic equation. I have 3r squared because we drop a degree. So the original problem was cubed. Now we go down a degree. 3r squared plus 6r plus 12 equals 0. Now, I don't have to leave it in this form. Actually, with that 3 being in front, I could divide everything by 3 just to make my life a little bit happier. Now, the problem is, which is funny, the hardest part about this is the factoring, you guys. Getting the general solution is usually not a problem. This doesn't factor, which tells me probably I'm going to have complex solutions. I'm going to use completing the square. That's just my preference. So I'm going to find b divided by 2 squared would be a positive 1. So then I get r plus 1 squared equals negative 3, which when I solve this and take the square root, we get r plus 1 equals plus or minus I root 3, which means we get r equals negative 1 plus or minus I root 3. All right, I have a real distinct root, and then I have distinct complex roots. So I'm going to have to use 2 parts of this. If all I were solving was this real distinct root, we would have y equals c1 e to the 1/3 t. if all I had was the complex roots, complex roots is what we did on Friday. If all we had was the complex roots, we would have y equals, I'm going to go to C2. Remember, we put the e to the alpha t in the front, and this alpha is based on, so this negative right here is based on this number right here, that a part. Do you remember that? Just pretend you do. Pretend like, yes, Miss Allison, I learned this all. I understand it all. Then this would be my next constant of coefficient. Oh my gosh. Constant of integration. C1. It's not a... Oh my gosh. Okay, it's Monday. You don't remember how to factor. I don't remember how to speak. Okay. So then this would be the cosine of root 3 t. And remember, this root 3 comes from... Oops. That's the pen. Hold on. Root 3. Right? Plus C3 sine root 3t. And again, that root 3 comes from...
Yeah, how do you know which one is in sine and which one is in the...
Doesn't matter.
Oh, that's true.
Doesn't matter. Now, if we were to write this as one complete solution, I'm really just combining the two parts. C1e to the negative, to the 1/3 t plus, and you guys, I don't really care how you write it. If you want to multiply it back in, sometimes you'll see this multiplied back in. Cosine root 3t. So the hardest part of these problems is really, one, remembering how to factor, but thank you, technology, for allowing me to have ways to cheat. And two, remembering what form we have. So real distinct roots, remember, is this form. We have that formula on the front, the C1 e to the whatever the power is t. And then the complex roots are a little bit messier. Remember, we went through the whole idea of Euler's formula. Do you remember talking about that? Yeah, fun. All right, let's try this next one. Did you do it?
It's like the easiest part of all.
I agree. The factoring part is the easiest part.
Well, and then everything else is
Oh,
like,
God.
just apply the rules.
Apply the rules. It's just all rules. That's what's nice about this unit. The good question, if we were to see fourth derivative, you would see it in parentheses.
Does y to the 2, but in parentheses also work? Like for the second derivative, or does that just not exist?
Oh, no, it works. That would work. You mean if you saw this?
Yeah, would that still be correctly notated?
Yeah. Parentheses up there indicate derivatives.
But what if there's
Ooh.
exponents that are multiplied?
Multiple and complex. This is fun.
Oh, no. Oh, come on, man.
No. I just never repeated it. So oh, I just got
Say that I didn't.
Do you always use one period about
If there were enough sections,
So in front of C3 and C4.
behind.
if there were enough sections, I would not teach any.
And not a side.
If there were enough. All right, so you guys, this has a multiplicity of 2. So we have positive I 2 times and negative I 2 times. So now what? It's messy. Okay? If I only had it one time, I would have y equals e to the 0t, which, yes, we probably wouldn't write this. I'm just going to show you for just a second. C1 cosine t plus C2 sine t. Agreed? But I don't have it once. I have it twice. So then to account for this other multiplicity of 2, I'm going to have te to the 0t, because this part right here, that extra t accounts for that multiplicity. times C3 cosine t plus, I know it looks like I have a lot of room, but I don't on my screen, plus C4 sine t. The C3 and the C4 are different, and they have that t in front of it. Now, this could certainly be simplified, you guys, because e to the 0t is kind of silly to write. Because it's just 1. And this repeated root has that extra t in it. So repeated complex roots, we just repeat the idea of complex, but then add in the idea of a repeated root. See, it's not so bad, right? Okay, great.